Technological properties. In this video, we are going to see the main technological properties of materials. Machinability. Machinability is the ease that a material presents to be cut or drilled. Machinability is directly related to hardness. A hard material is difficult to scratch and will also be difficult to cut or drill. That's to say, hard materials are not very machinable, but soft materials are very machinable. Ductility. Ductility is the capacity of materials to be stretched into fine threads when subjected to tensile drawing. Wire drawing consists in passing a thread through a hole with a smaller diameter to reduce the section of said wire. An example of a ductile material is copper, since most conductive wires are made of copper, or aluminum, which is also a ductile material. Malleability. Malleability is the ability of materials to transform into thin layers like paper. The aluminum that we use to wrap a sandwich is an example of a malleable material. Ductile and malleable materials have to present a great plasticity, and at the same time, they have to be capable of becoming deformed without breaking. Fusibility. Fusibility is the ease with which a material can melt or be fused together. In this property, the melting point is important, which is the temperature in which a substance changes from a solid state to a liquid state. The lower the melting point, the greater the fusibility. Stone and iron are fusible materials since they can melt at high temperatures, but silicon is even more fusible than the previous materials given that its melting point is lower. Castability. Castability is the capability of a molten metal to fill a mold and produce a complete and complex parts. In order for a metal to be castable, it has to possess a high fluidity, meaning a low viscosity, when it is in a liquid state. Weldability. It is the ease with which a material allows to obtain homogeneous and high-quality welds. Welding is mainly used for joining metals and plastics. Forgeability. Forgeability is the ability of metals to undergo sculptural deformation without breaking nor developing defects, which can be hot or cold. Work hardening. Work hardening is the property of a metal to increase its hardness, its resistance, but also its fragility when cold deformed.